Ta-da! Hey everybody, this is Mark D'Antonio with SkyTour LiveStream. We are looking at Comet 46P Wharton, and it is a marvelous comet that is in our local space at the moment, and it's going to be approaching us even closer. It's not quite all the way here yet, but it is about 2.6 million kilometers away, and that's 0.7 light minutes. It takes 0.7 minutes for light to get here from that comet, and the brightness around the comet has increased since the very last time we actually looked at it. We don't see an appreciable tail yet. We're just seeing the outgassing on the nucleus, forming what's called the coma of the comet, and it circles the sun every 5.4 years. It's called a periodic comet, and we can see in this view here, as I will actually zoom in a little bit, we can see, let me move it up, we can see that the comet has this bright area in the center, and it seems to be trailing a little bit toward this side, and we'll expect to see the tail form on this side of it when it gets a little bit closer to the sun, and that'll be very interesting to see. Now, as far as the what the comet's made of, well, you know, that's that's common knowledge that comets are made of course, water, but they also have other compounds on them too, some hydrocarbons, and these compounds called tholins. That's Tholins. So look it up, check those out. And the cometary nuclei they're various sizes. I mean, some of them can be a few kilometers across, and of course they will eventually evaporate each time they come around the sun, and each time they come around the sun it's called an apparition, kind of like a ghost, an apparition. And these apparitions that we see here will eventually be smaller and smaller as the comet evaporates each 5.4 year cycle around. Now, the comet could also break apart. We've seen that before. And with 67P Churyumov-Gerasimenko, the one that the Rosetta mission actually landed on, with the Philae lander, that particular comet already has two very distinct lobes with a tiny little waist, kind of like a wasp waist. You know, it's a narrow area that's connecting the two pieces. Eventually, those will probably break apart, and it'll be a dual comet, a twin comet. Philae is trapped in a crevice, but that's only a temporary condition, because at some point Philae will be freed as Churyumov-Gerasimenko makes its 6.4 or so year circuit around the sun itself, because that's also a periodic comet. The other thing that's interesting about this particular comet is that it's a comet that has a short period, and short period comets were very attractive to the folks that were trying to figure out if they were going to go land on a comet. So originally, it was this comet right here that was the target of the Rosetta mission. All right, and they eventually changed to a different comet, because this one managed to elude them. It got by before they could actually launch safely, and unfortunately it ended up not being a viable target at the end. So you can see they have this distinctive green glow, and that's typical of comets. They will have a greenish look to the eye in the sky, and I think that the constellation we're in here is called Cetus, C-E-T-U-S, and Cetus is the whale, I believe. I told Amanda that we'd be streaming a little bit later tonight because I had a issue adjusting the telescope, because I had changed over to a new system for the mirrors, and it ended up causing a couple of problems, which took me a little longer to correct. You can actually see the problems are still occurring out here, but for the viable part of the image, we're okay. And that's what's important. So that said, we have this this comet. Now, like I said, it's basically 12.6, actually 12.6 million kilometers away. I might have said 2.6 erroneously, I think. That's 0.7 light minutes, as I said. So it'll be its maximum. It'll be at its maximum. Well, I should say nearest minimum distance to the Earth on the 16th. So in about 6 days. So it'd be pretty cool. So I'm glad you can join me tonight. We're only gonna stream for a little while because it's 8 o'clock now, my time, Eastern time, and at 9 o'clock I have to go on with Alan Smith. We're gonna be doing a live radio show on Spreaker, and it'll be rebroadcast on KGRA, I believe, on a Thursday. It might be this Thursday or next. I'm not sure. And Alan Smith's a real sharp guy, and he's actually one of the newest additions to the KGRA radio host staff. So it'll be kind of fun to go on and check that out. So once again, this is 46P Wirtanen. It's basically a third magnitude comet, basically. And I think that it's probably, like I said, the 16th is going to be the closest to us. Okay. Now, actually not third magnitude, sorry. It's actually quite a bit fainter than that. I'm not actually sure of its actual magnitude at the moment. It was actually, it's changing, of course, every day, so I'm not sure what it is now. But it should approach a little bit. I think it's a little less than naked eye visibility. You're still going to need a telescope to see it. And just because, just to be honest, I mean, there's plenty of comets that are out there. Just to give you an idea of the comets that are out there, I mean, 46P right now is the brightest one. It's around magnitude 4 at the moment, actually. And there's another one. There's Stefan Oterma, and that one is in the constellation of Cancer, which is farther eastward actually of Orion at the moment. And that's magnitude 9.3. Okay, this is a magnitude 4 comet. Now, to the eye, this is a very, very faint smudge. Okay, so then we have Swift-Gehrels, which is 64P, and that's in Triangulum, which is visible, but it's 12.2 magnitude. So it's starting to be fainter. The larger the numbers, remember, the magnitude, the fainter the objects are. Then we have Cairns Cui, which is 59P. Notice the P; these are all periodics. They're always coming back, And those comets are all magnitude 13, magnitude 14, and so they're actually the brightest comet we have right now is this one we're looking at right now, and of course that's why everybody knows about it, isn't it? Because we're enjoying this one. So that said, we'll come back to this in a little while, but keep in mind we've got all these pictures over here that we took of it. And when we come back, we'll take some more pictures and see if you remember that little star right there. Okay, see that star right there? We're going to see that star right there and see how far this is from that star in just a little while before I have to go on the radio. And after the radio show, by the way, which goes to 11, I'm actually going to leave the dome open, and I'm going to probably do more imaging and more streaming after that. And I can't leave the stream going during that whole time because I suspect that we'll end up having a problem trying to leave it open because I've got ice buildup that occurred on the lens and the telescope mirror. The end of the telescope is a Schmidt-Cassegrain, so it's a piece of glass basically. So that said, I think we'll probably just turn the stream off at that point in a little while and then come back to it. All right. So I'm getting the chat up. I'm hoping Amanda will join us in a little while. If I didn't really give her an actual time, so if she's confused, it's definitely probably my fault. So I didn't know if I was going to get this working, frankly. So in any case, we're looking at this here, and what I'm going to do is I'm going to take us to another object, and we're going to come back to this. Okay, we're going to come back to the comet. That's a promise. All right, and when I come back, we're going to actually be able to check out a little bit different it'll be in a different position. That'll be kind of cool. All right, so let's go over to our remote, which is our remote site, which controls the camera. And let's see what we got. So we're going to go into that site right now. Okay, here we go. And it doesn't look like much, but here, let me actually just do a 4K video. Let's do this video, and we bring this video up, and you can see the comet right there. This little faint stuff. This pink stuff you see on the sides, that's called amplifier noise. It's actually an artifact of the camera. But let's actually increase the ISO to the camera, and you'll actually be able to see the comet very much more clearly. There it is, see? And in a telescope where you're looking at it through an eyepiece, that's kind of what you're going to see, a little bit fainter than that. All right, and this is going to go racing across the sky, probably in this direction, but we'll check it out when we come back. And remember, this is all in 3 dimensions, so these stars obviously are light years farther beyond us than that comet, but they all kind of tend to look like they're all in the same place, don't they? So let's go take this back down, and now let's go over to the other object that I want to check out with you before I had to go and do the radio show, and that is the object for which I actually wrote a big post yesterday, Messier 77, which is the it's in the same constellation in Cetus, okay, and this is actually in the constellation of Cetus, and it's you can see the stars moving as we're moving the telescope, and the galaxy is actually called Cetus A, and there was a supernova that occurred in this galaxy at the end of November. And when supernovas explode, they don't just go boom and then they just go back to their same brightness, that they were, or they just dim away. It takes them sometimes weeks or months to actually dim out. This is a long process. It takes a long time. Now, it's short time relative to the lifetime of the star, of course. But in terms of other qualities, it takes quite a while for the supernova energy to die down and for the radiation to stop ionizing gas, which causes it to glow, like we see with star-forming regions and so forth. So there's a lot of considerations here. So this, I think, is just a very interesting location. Let's take a picture, and in fact, I'll show you what I'm seeing. This is what you're going to see now is what I'm looking at. Okay, let me just get rid of this guy. Okay, this is the whole control panel that I'm using for the camera over here. All right, so we're going to do 15-second exposure at 16,000 ISO. All right, here we go. We're going to click that, and now the camera is exposing, and we shall see the galaxy just show up in the middle here. Well, I'm not sure if it'll be right in the middle or if it'll be just sort of off to the side a little bit. But when it comes back, we'll see. And then we will actually proceed to... okay, it's not bad. All right, not bad at all. Okay, and now what we're doing is we're doing a little image processing. You can see it occur on the screen there. And let's go into the view mode and get into close-up mode. All right, and now let's zoom in just a little bit. Let's see if we can see something. All right, so we move this over. Now, when I took the picture last night, the supernova was right here on the very top part of this edge of this brighter part of the galaxy. And it may still be there. Trouble is, I may have to change the settings to make it more visible. So that's exactly what I'm going to do. It takes time. I got a beautiful view of it, though. I did manage to get a really, really nice view. So I'm going to drop down this sensitivity right down to 6400 and go 15 seconds again. So you see the 6400 here and 15 seconds. And let's take another picture and see what we get. Now, the higher the ISO number, the more noise we get in our picture. That is, the more graininess we'll see. And that's a function of the sensor basically being taxed, basically, to produce more information. And when you stretch that data like that, you end up getting a very different view, which could actually be less informative. Okay, we're still seeing some issues here. Got to get a few of these things to clean themselves up. And let me just zoom in a little. Yeah, this actually can't see it yet. I don't. Actually, there it is. You can see it right there, right the very as this arm's coming around here, right just above that arm, right at the at the index finger of this hand. You can actually see the supernova right there. That's it. We've reacquired it, and this color thing here. This is actually a function of some noise on the camera, which we process away here. But right above this, you see this sweeping spiral arm right here in this galaxy, which is 46.9 million light years away. In this sweeping arm of the galaxy, there's this little tiny dot right there, just above the top of that, almost at the very top of that spiral arm, and that's the supernova. There it is. Now, that's an exploding star that took out a massive amount of space around it, and filled that space with a whole lot of potential radiation. Now, as far as that goes, I think that when we talk about doing this kind of imaging, we also have to keep in mind that when we're actually focusing on like an object like this galaxy, we might actually miss out on some of the other stuff we're trying to do. All right, we might actually miss out, for instance, on other beautiful things going on in this galaxy. This is a very nicely wound spiral, and it doesn't look too much like a spiral here. You can kind of see it, and that little fuzzy thing you see right there is the supernova. And if I zoom back out and come in just enough, you can actually see it. I see Jello's here. So there's Chris Elliott. Hey, Chris, how you doing? Hey, Daryl. Hi, Dee Dee. I see you guys have joined us. That's nice. Thank you. I'm going to be here, like I said, for just about another half hour, and then I have to go and get ready for the radio show that I'm doing. Hi, Melissa. I tried to get Amanda online to she was going to join, and she was going to join when I said I wanted to do this, which was at 6:30. Unfortunately, I had a problem with the camera, and I couldn't actually come in at that point, and there was no way to tell all of you this, Hey, Ashley, how you doing? And I think that the nice thing is that we got a chance to actually see, the galaxy supernova here, and we got to see the comet, the 46P Wirtanen, a few minutes ago. For those that just got here, don't worry, we will get back to it. We will get back to it shortly. I'm letting it move a little bit, and we're going to see if we can compare where it is then and where it was. Now, this is actually the comet from just a few minutes ago. We just took this picture here a few minutes ago. So what I was saying was, notice this comet here. This is the coma. This is the bright area around the comet. All right, it'll have a tail at some point. Not yet. It's really not showing up yet. All right, a little bit. And then this star and this comet, you see how close they are? We're going to look at them in about a half hour and see the difference between where this is now and what we see when we get there. Be kind of cool. That's a really neat thing to do. So that's really cool. So I'm believing that between the comet and that supernova we just imaged, I think that we're actually seeing some pretty cool stuff tonight, and I know that we'll be able to get a better view. This is a little bit, the comet and this galaxy are a little bit in the murk right now, but even so, you can see that little dot just above this, right above this arm here. You can see this little tiny protrusion of more signal, so to speak, and that is actually the supernova out there. And let's go back to the remote for now. And this is our automatic remote. And again, this is what I see. And I want to show you what I see so you know what I'm doing. Okay. And let's actually do, let's go down to 5,000 and do 20 seconds. Now, those that know photography know that if you increase the exposure by 1 and go down on the ISO or sensitivity, it's the same overall light gathering. Okay? However, the lower this number, the lower this sensitivity, the less grain that we'll see in the image. So maybe this will present us with a little bit less, and let's see what we get. Okay, so it's pretty cool. Now, I'm really certain that we'll be able to we'll be able to actually really see the movement of the comet. I'm not worried about that. What I'd like to do is to show you the supernova a little bit better. Now, keep in mind that the image that I put up on Facebook was 32 images stacked together. Okay, 32 stacked. Okay, so it was just a little bit, stacked in my. The odds are stacked in my favor. Okay, now you can actually see this a little better. Right above this area, this brighter area in the center, you can see this little white dot right above the index finger of this hand. Okay, it's actually not quite stable. Let me get a little closer. Okay, right there it is, right there, right above the index finger is this little tiny white dot, and that is the star that has exploded in this galaxy 46.9 million light years away. Now, for those that didn't read my Facebook post on this, keep this in mind. We're seeing the light of this galaxy. We're seeing the combined starlight from billions of stars, making a soft glow that we can see. We can't see the individual stars. But in supernovae, we see the individual star that's blowing up. And that's what we see here. We're seeing the individual star. That tells you right there that by seeing this one individual star out of billions from this distance, shows you that you have an awful lot of energy being put out on this star to be able to see that. And that is crazy. That is an amazing amount of energy. So much so that it's actually, well, okay, I'll give it to you this way. The sun is going to live 10 billion years. All right, we're about halfway through that. This supernova, at its maximum output, could very well produce the output that the sun puts out in its entire 10 billion year lifetime, just in the supernova event. Is that not amazing? I mean, that is incredible. Now, another reason why we may not be getting the stars as clear as possible is because of this other stuff here. You can see this slight teardrop shape. Part of that could be a little guiding error, but it's also probably due to the fact that the scope is out of what's called collimation a little bit. I replaced the collimation control system on the telescope with this other design, and I'm working on trying to get it to look a little better. So, and this fuzzy stuff you see all around here, this is that noise I was telling you about. You want to minimize that, and I have algorithms, for instance, that I can use, which can go through this image right here and remove all this modeling. All right, and the problem is that it doesn't replace it, right away with good data, and that's something else that is a problem. So that said, it is what it is. Anyway, I'm looking at the screen here, trying to figure something out here. What do I want to do? I think I'm going to go back to the remote here a minute and go back to my remote live. What I'd like to do is I want to I'm actually going to reduce the exposure back to 15 seconds, or 5 seconds lower, but that's stop. All right, and we'll leave it at this ASA or this ISO of 5000. And now I'll take another picture and let's see what we get. I'm trying to maximize it for an instantaneous view. Hey, Laura Hovey, how are you? All right, there we go. And Cosmic Lettuce. Yeah, very dark southeastern Arizona. Yeah, I know, huh? I'll be there in about a year and a half. I will. Okay, so now we're going to be looking at this, and I'm seeing. See, what we're actually seeing is you got to. Here's why you have to take lots and lots of photos, because the instantaneous photo may not be the best, and what we do is we throw those out. So I'd have to take maybe, I don't know, 5, 10 of these photos of something that's really, really small like this to get one perfect one. And then I take that one perfect one and add it to another group of perfect ones that I might take. And that one becomes, those all become the final image when we stack them together. The nice thing about this new system that I'm showing you all here is that I'd be able to show you, and I will be able to show you, how we actually do all that and how we actually do stack the imagery together to make a final beautiful image. And that's something that we'll do. Yeah. Now I just have to put you all on hold for just a second, so hang on just a moment. Just a second here. All right? I'll be right back to you. Okay, I am back. Now, let's see. I am looking at the time here. And, oh, well, you know what? Here's what I'm going to do. In order to prepare for this, I'm going to terminate the stream now, because I have to also shut down the, I just got to close off the telescope. And there's some packs of coyotes outside, so I'm going to have to go out there and be a little bit cautious. And I'm going to go out there and do this and find out where they are. And I will be back after I do the 9 to 11 Eastern Time show with Alan Smith. All right. So I want to thank you. We looked at the comet today, and we're actually, after looking at the comet, I think it's kind of cool that we were able to see the comet. And when we come back tonight later, we'll see. Let me get you the comet here right now. This is the comet as it was just a little while ago. And we'll be able to come back and check this out in a little while and see how much closer or farther I'm predicting closer to that star that it got. So that's pretty cool. So I'll be back in a little while, and I shall talk to you guys a little bit later. Thanks for joining me, and I'll see you in a little while.